Hello and welcome to another tutorial. So this time we are going to be continuing to extend the procedural based terrain generation. And one of the big things that I want to be doing with this is I want to change fairly heavily how we support generating biomes. So at the moment the way that it works is, the biome it picks for a particular location is essentially entirely random. You can have weightings of that, but otherwise it's entirely random. So I'm going to make that a little bit more sophisticated so that could support things like what Valheim does, where you have particular biomes that spawn in the north, particular ones that spawn in the south, and you can control sort of the likelihood of a biome based upon radiating out from that center point. So that's what I want to actually get up and running with this. So let's dive on in. So there's going to be a few things that we need to do to accomplish this. One of the big things is that we're going to need to change around how we actually work with the points. So at the moment we have two different sort of methods for selecting the biome that each one uses. So because we have our ooze-based and our Veroni-based biome generation, and Veroni is pure random, and the the ooze-based one is a weighted random. So what I want to do is I want to actually move all of this into the base class for how it selects what biomes get generated or what biome is going to be used, and make it so that we've got options in terms of how we actually do that. So I'm going to go to the base biome one here, and this is where I'm going to set up a lot of the particular things. So one of the first things that I want to actually do is I want to add in an enum, and this is going to be the biome selection mode. So this is going to be how we decide which biome to use. So what we're going to have is pure random, which is what the Veroni currently uses. We're going to have our weighted random. And then we are going to have our location based. I might actually refer to this as zone based. And it's still going to be incorporating weightings, and it's still going to be random. So I'm going to call this zone based weighted random. And it's going to be the ideal version. It's going to be the one that probably we would use in most cases. So, okay, that's good. I'm also then going to need to obviously store that. So we'll have our serialize field. We'll have our biome selection mode, which we will default that to pure random for now. And then, okay, good so far. So what I want to do is start to look at how I would refactor some of the random selections. Now, zone-based one, it's going to need to take into account locations. So that's going to mean from a biome picking point of view, I'm definitely going to need to pass in locations. So what I'm going to do is I'm going to have protected byte pick biome type, which it's going to bring in the procgen manager and the generation data. We have to do that so that we have our actual random number generator, so we're using the correct one. And then I need to provide the location. Now, with the location, Veroni works with the entire map, whereas the ooze-based one works with a low resolution that it then scales up. So what I am going to do with this is I'm going to have it that we pass in a normalized location. That's going to be something then that it can be resolution independent. We don't need to worry about making sure it's using the exact right thing there with that. So it's going to make it a little bit easier for us. So our fallback will actually be the pure random one, which that's going to do a generation data random from 0 to generation data, and we access config and num biomes. And we just need to cast that to a byte. So, okay, that's our fallback one that any of the particular ones could use. And so let's start to get this integrated. And as we get it integrated, that should hopefully give us an idea of what other things we might need for this. So, okay, we can see here how it's currently picking the biome. It's just doing a pure random there for that. So what I want to be able to do is this would actually be a pick biome type, generation data, and then we need our normalized position. So that normalized position, I'm going to set up a vector2 here for it. And it can be vector2 0 to begin with. And then I need to calculate it. So this should be a number that generally goes from -1 to 1. So the bottom left-hand corner of the map would be -1, -1. Top right would be 1, 1. So that's going to be the general sort of setup for it. It gives us a normalized coordinate in that range. So how I would calculate that is reasonably straightforward. What I would do is my normalized position dot x. So I want to use the x location that we've calculated here. And I want to divide it by the maximum value this could be, which is going to be our generation data map resolution. Now, this, because those are both integers, that will actually run into issues. So it's something to always be careful of if you're doing integer division, that you can easily run into problems there where it will stay as an integer, which means most of the values that come out of this would be 0, which is not really ideal. So I'm going to, now, strictly speaking, only need to cast one of these to a float, but I'm actually going to cast both of them to a float, just sort of force of habit to make it very clear what's actually happening. So this would currently give me a 0 to 1 range. So to convert that to the -1 to 1 range, there's a couple of ways I can go about doing that. What I'm going to do, and I'm just going to do this on a second line here, just to make it a little bit clearer for what's actually happening. So do x minus 0.5, like that. So now we will have a value that is minus 0.5 to 0.5. And then I multiply that by 2. Now I do the exact same process for calculating the y value. This uses cell index y. So that's pretty good. That's going to work the way that we need. Now, the ooze-based one, we need to make a little bit more in the way of changes to it, just because it's a little bit more complicated what's actually happening with it. So, in particular, with the ooze-based one, we've got a lot of stuff here where we're setting up the seed points with the weighting and the biomes to spawn. And actually, all of this is something that we want to move into the base class, because we want the base class to be able to support the weighted spawning. So what I'm going to do is here have a protected void prepare to spawn biomes. And this list of biomes to spawn, that's something that we can have here, like this. So it'll be something that we hold internally. Strictly speaking, don't need to set it to null, it already will be, but force of habit, I always tend to initialize variables in C# when I don't need to. Part of that is because I do a lot of working in C# and C++, so I want to make sure I don't fall out of the habit in C++, because it actually is very important to make sure you do that in C++. So that's the main reason you'll see me do that in C#. I think it also is good to make it a little bit more explicit what's happening. So, okay. So far, so good. And we just need to update that. So that looks all right. That means our Biome-based one here, we can do our prepare to spawn biomes, generation data, and we use num cells by num cells. The advantage of this, what we're doing is we're enhancing the Veroni and also the ooze based at the same point in time, and we provide something that's generic that they can all make use of. So, okay, the ooze based one, we can then go here, well, prepare to spawn biomes, generation data, and our num seed points. Actually, I could do this. There's nothing stopping me from doing this here, like that. So, okay, good so far. A bunch of this also applies for when we're doing the picking of the biome. So we can see this for picking a biome. Well, what I'm going to do is come over to here and check, okay, well, if our mode is equal to weighted random and biomes to spawn is not null, and we have one still valid in it, then what I want to do, so the idea is it always has something it can fall back to, which is the pure random. So we return biome index. So this just changes like this. So now our Veroni-based one would work with our weighted random as well, which is great. And our ooze-based is very close to being working the way that we need. So our biome index, well, I would do pick biome type, generation data, but I need that normalized position. So I need to make a few more changes to this, because here I want to actually pass in normalized position, although maybe not the normalized position. I think probably we pass in what we actually calculate here in terms of this location. So what I'm going to do is grab our spawn location one and bring that up here. We'll into the spawn individual biome, we'll provide spawn location like this. So that's so far so good. Map resolution, all of that looks good. We haven't calculated the normalized position yet, that's fine. Here we just need to add in a vector to int of spawn location. So, okay, so far so good. Now for calculating the normalized position, it's a reasonably straightforward calculation. Normalized position, we'll do similar to what we did, so we're not constantly newing a particular one. So we'll have our normalized position x, And what that's going to be is we take our spawn location .x divided by map resolution. We again do the same casting to a float so that it does the conversion okay. And then we can do the same minus 0.5. And in this case, I'm going to do it all in the one line, because we've seen doing it as separate lines, and we can also do this all in a single line as well. And that's normalized position Y. So that's good. The only thing left to fix here is this biomes to spawn count. So has biomes left to spawn, which what I will do is I'll set that up here as a property. So a protected bool. So this can check if biomes to spawn is not equal to null and biomes to spawn count greater than 0. So that's good. That should mean we have this largely working in terms of we won't see a change in the biomes that it's picking, but everything now supports using the weighted because we have that happening for our ooze based, it does the prepare to spawn, and we do the same thing for Veroni. And both of them are using that pick biome type. So they're going through that same interface. So that's good. That should mean with this, I won't see anything really in the way of differences, in that if I regenerate it, it's still going to be following the same methods for picking the biome types. It's still going to be weighted. The difference is that the Veroni one is now able to use the weighted ones, whereas before it couldn't. So we have our ooze based, which is using pure random. Veroni can change these to both to weighted. And then if I generate it, so it's still going to look fairly similar, but it should be using the weightings that we've configured in the actual ProcGen setup. So that's good. We've got our setup going that we can now start to support zones. And this is where we start to get some really cool things happening with this. Because what we can do is we're going to set up what our zones look like. So what I want to be able to do with the zones is I want to be able to say, okay, with out to a certain radius from the center, this is the probability of a particular type of biome, and be able to have a case where, okay, some of these biomes only spawn in the north, or some only in the south, or east, or west, or things like that. So that's what I want to be able to support doing. So what I'm going to do, and not in the ooze based, we actually can just go back to our base one, so that everything is able to support this. So I'm going to have a system serializable. I will have a public class. I can get rid of the using static ProcGen manager. Autocomplete sometimes goes a little overboard with things it adds in. So we can have our zone config. So zones, well, they need to have a biome config that they map to. They need to have a distance, so a min distance, and we'll also have a max distance, like that. We want to then be able to vary the weighting of the biome between those distances. So we'll have an animation curve, and this will be biome weighting versus distance. where 0 on the time axis will be our min distance and 1 will be the max. So it just allows us to easily control that, which will work nicely. Then we want to have our angles. So the easiest with this is going to be specifying those on a 0 to 360 range. So this is going to be our start angle, which will be 0. Actually give these some useful values. And we'll have our end angle, float, end angle, and that'll be 360. Now, angles are a tricky one because we want to easily be able to say, cool, here's a segment, and within this segment, this biome can be spawned. But it's also useful to be able to say, okay, this only applies outside of this angle. So I'll have inside of angle. This just makes it a little bit easier for working with it. And then down here, we want to be able to, not selection mode, we want to have a list of zone configs. And I'll call that zones. And we'll use the simplified new option. So that's good. We can now set this up and configure our zones just so we see what they actually look like. And we'll change the naming of that to zones with an S. Works a little bit better. Okay, so I'm working with the ooze-based one here. Veroni is the one we're currently using. But what I'll do is, okay, let's add in our first zone. So we set up our angles. The defaults for this, there is an issue with Unity where it doesn't work nicely with that. Okay, I'm going to look at our different biomes, and we're going to make it that grassy plains is very, very prevalent in the center, so close to that min distance. So I'm going to set that value to 1. And then we might say that at 1, it actually goes to 0. We could even have that happen a little bit earlier so that you get no grassy plains beyond a certain point. So we could say 0.9, its value is 0, and adjust the right tangent like that. So that looks good. So, okay, grassy plains will be in the interior. We add in another one, and we might say that bush also has a similar setup there. Seems to be some issues with those sliders with what they're showing for the values. It looks like it's a visual bug more than anything. What I will do with this is this one can go that full range. Still allow it to go to 0 at the very edge, but then the next one that I set up, which this one, so definitely a few UI glitches happening there. So we've used bush and grassy plains. So I'll say scrub is for this one, and scrub, even at the very edge, we'll say that there's a 25% chance of it, but we might lower it on the areas closer in. So it's less frequent closer in. So that's good. We've got bush, grassy plains, and scrub set up. Then what I will add in is I want rainforest to the north. So this, I'm actually going to change it so it's just fully constant. And distance, I only want it to be fairly far out. So I'm going to say it has to be between 0.75 and our max. And our start angle, well, to make this in the north, I want to say, okay, let's say 45 to 315, and I turn off inside of angle. So that's going to mean rather than it defining that it has to be within that large arc, it has to be in that narrow area that it doesn't cover. So that's going to do for the rainforest. Then I do kind of the opposite for swamp. So the other values stay the same, but the angles go to 135 and 225. Is that right? 2, yes, that is right. And we go inside of that angle. So, okay, that looks pretty good for the setup for those. I'm going to use the exact same one for ooze based, just so we've got all of those configured. Now I need to make them work. That's going to be the big test, is making these actually work. So, how this needs to happen is in our biome picking down here, I need to improve this a little bit. For one thing, if I have to embed the code for each thing in there, it's going to get very messy very quickly. So what I'm going to do is have a byte pick biome type weighted random, and put the code here, bring these in like that. So if it's that, then all I need to do is go return pick biome type weighted random, provide everything like of that. We'll do a similar thing for if the mode is our zone 1 and our zones not equal to null, and we check the count, then we'll have, and it won't be weighted random, it will be zone based weighted random, but it again will get the generation data and that normalized location. So we can set up that function. So pick biome type zone based weighted random, and we just bring in the same parameters, and we'll need to obviously return, make sure we get the spelling correct. So okay, now what does this function actually look like? Well, we're going to need to evaluate all of the zones to see what ones are actually viable at that location. So I'm going to need to loop through the zones like that. And then I need to check the actual weighting. And I also need to check if the location is within that zone. But I can combine those two, because a valid weighting would have to be 0 or above. So I'm going to say, okay, not in all caps, weight is our zone, and I want to be able to do something like this where I get the weight for location. And we'll call it a get weight for location. And I give it the normalized location like that. So I want to have something like of that, and if the weight is less than or equal to 0, then yes, we will just do a continue. Let's bring that up onto the one line. So, okay, so far so good. Get weight for location we won't implement just yet. I'll just put in a very, very bare bones skeleton. Public float, vector2, normalized location, and for now, I'm just going to always return -1, just so I can implement more of the rest of this. because we've got two kind of sides to it: the actual working with the weighted data that we've got, and then being able to process it. So, okay, I need to store a list of the zones that I've selected, and I also need to make it easy to be able to know sort of the weighting to pick, so I can do the random selection of those. So what I'm going to do is, this is where it can be really handy to use this thing called a tuple, which can be a handy way to just slam together a few different related bits of data. So in this case, it's going to have a byte for the biome index, and it's going to have a float for the biome weight. So this is going to be our weighted biome options, like that. And I'm going to also store the total weight, which I'll initialize to 0. So here, what I would do is, okay, well, the total weight gets the weight added into it. And I would also add in to our weighted biome options. So I add in, and I add in a new tuple. Well, I need to get the biome index, which I don't currently have. So I'm going to have byte biome index. For now, I'll just put a 0. So I can say biome index. Now the weight, as I add in each new biome, what I want to be storing here is essentially what I need to roll to be able to select this biome. So this is actually going to be weight plus total weight. So that looks good, because what I would then do down here is, well, if our total weight is greater than 0, so in other words, we've found valid options, then I need to do my random roll. So my random roll, I use the generation data, a random from 0 to the total weight. That's why I stored that. Then I just go through our weighted biome in our weighted biome options, and then I check if the roll is less than or equal to a weighted biome and the actual weighting that we stored here, which will be item 2, then I can return weighted biome item 1. So let's do that. Now, it's possible that we could end up with absolutely nothing being picked, in which case I just want to pick a random biome. So I will have this as our default down here, just in case it fails to pick something, which could happen. If there's, we misconfigure the zones, it could end up with absolutely no biome, so we want a safe fallback here. So, okay, so far so good. This, I obviously need some value for this, so I want to be able to ideally do something where I can go, hey, generation data, and the config, because the config has all of the information, get biome, or get index for biome. So get index for biome, and we say zone, biome like that. Now that could fail. So if biome index is equal to byte max value, continue. So if for whatever reason it failed to retrieve the biome, then I want to be able to have that safely handle that. So then in our config, what I want to have is public byte. We provide the biome config. Our fallback is to return byte max value. Now, this would end up being an issue if we ended up with as many biomes as the same as max value, but for that we would need to have over 200 biomes, which feels unlikely for us to have. So now I want to find the index of the biome. So I'm going to go for index is 0, index is less than biomes count, and then we check f biomes index is equal to this one. Then we return, so not index like that, we do biome, and then we just return byte of index. So that's good. We've got our weighted picking happening here. Now, the only thing we don't have going is this get weight for location. That's the last bit we need to make actually work. So let's go up to this and let's look and see what we need to actually be doing here. Well, firstly, distance is something that makes the most sense to check initially. So we're going to get the distance. So that's going to be our normalized location magnitude, like that. Now that will mean in things like the far corners, it ends up being a value that's above 1, which is not necessarily ideal when we're limiting these to be between 0 and 1. So what I might do here is a clamp like that, so that ones in the far corners will still actually register validly. So, okay, first thing is to check, are we outside of that distance? So if distance is less than our min, or distance is greater than our max, then we return -1, because it's not a valid location. Then I want to get the angle, and the angle is the trickier one for actually assessing here. So what I do is the angle is going to be a mathf a tan 2, and we use our normalized location x and a normalized location y. Now, this is swapped for what the order of the parameters says. However, with how the terrain and everything is positioned, how the data is organized, this is actually the correct way that we want to have this work. But the worst case of if you have these around a different way is that things are going to be rotated. So it's not a big deal. And you may actually want that. Now, that angle is going to be between -180 to 180. We're working in a 0 to 360 range. So if the angle is less than 0, then we do angle plus 360. That's going to make things work a little bit better. Now we want to check, okay, well, if we're having to be inside of the angle, then, well, if that angle is less than the start angle, or the angle is greater than the end angle, then it's invalid. Now we have the other scenario where we want to check kind of the reverse case. So what we do instead in this is if the angle is greater than or equal to start and it is less than or equal to end. So if it's actually validly between them, then we don't want it. So that's good. So, okay, we're looking in a pretty good spot there then with this. Now, all we need to do is down here, we can actually evaluate our location based upon the distance stuff that we've set up. So what we can do is we want to do biome weighting versus distance and evaluate. Now, what we want to do here is we kind of want to, because min and max distance could be something other than 0 and 1. So what I'm going to do first, this is a case where the inverse lerp is actually really handy. So we have our min distance, we have our max distance, and then we have our distance value. So that, what inverse lerp gives you back, is it determines where it lies between the 2 points. So I'm going to use that here into our evaluate. Like that. So that should work pretty nicely. Now for testing this, the easiest way is actually going to be looking at the biome maps that we get. So if we take a look at what the biome maps currently look like, this is what the Biome-based one looks like at the moment. It's pure random. So let's see how it looks now with what we've got is it's the weighted random. I'm going to switch this to zone-based weighted random. Save everything because I've been bitten enough times to want to make sure that it doesn't crash. So I'll tell it to regenerate. So we haven't gotten any errors, which is good. So it ran, and if we take a look at what the map actually looks like, we do notice it has got the clusters, but it's clearly not working entirely right. So if we go and take a look at the code, one of the important things we missed with the angle is this needs to be converting it to degrees, because we're working in degrees with everything and we weren't doing a conversion, so all of the values there would have been quite far off. So let's test this again and tell it to regenerate. So that's now run, and it's going to continue doing the updating, but that's enough for us to take a look at the actual map, and we can see we have biomes that are oriented based upon where they are located. So we updated the Biome-based generation. Now the ooze-based generation is still using the weighted random setup if we take a look at it. And so it's only using that. And we very specifically don't want to test it with the zone-based one at the moment because there are actually some issues we'll run into with that. So what I'm going to do is a couple of things. Firstly, where we go and set up our prepare to spawn biomes, well, this is something where, okay, setting up our biomes to spawn only makes sense if we are using the actual one that uses that. So we want to check if our mode is not equal to our, so not the pure random, but the weighted random. So if that's the case, then we set biomes to spawn to null, and we return. Now, the issue that we will run into is this has biomes left to spawn, because currently the ooze-based one uses that. So that works for the mode where we're actually going and randomly selecting from that weighted set of ones we've put together, but it doesn't work for the location-based one. So what I'm going to do here is change this to 4. Biome count is 0. Biome count is less than the number of seed points, like that. That's just going to mean that it doesn't infinite loop if we're not using that particular mode, which what I might actually do is, just to prevent confusion with it, I will actually go and get rid of that. So that looks good. So let's test this out. Firstly, keeping it with the weighted random that it currently has. We expect to see the map here. This is the kind of chaotic mess we get. Now if we change ooze-based to the zone setup and regenerate it now, then what I should hopefully see when I look at the high-res one is we've got some clear weighting happening there. Now, it does look like things are a little bit off. So we do just want to go and check that we're providing the right location. And we can see we got that mixed up, so it wasn't providing both X and Y. And we're going to double check for the Biome based one that we did the correct thing, which we did. So ooze based, we had that wrong. So we'll just regenerate again. Now this time with the map, we can see we've got our green at the top, our purple at the bottom, and the smattering of other biomes scattered throughout it. So that's good. We've got that working quite nicely. So that's working well. Now, something that was raised from memory in a comment was in terms of with the slope map, and this is a good thing to look at as the final sort of aspect for this, is where we were setting our slope map. And at the moment, I was using the interpolated normal. There is another function that I can actually use, which is get steepness. Now, I did a bit of testing just to see what we get back with both of them, and they're actually pretty similar. The difference here is we divide that by 90, so it doesn't come out as something that has an X, Y, and Z component. So we divide it by 90, so it does work a little bit better. It does mean that when we're specifying the angles, they're a little bit, there's more of a direct mapping from things like, so if we go and take a look at texture painters, so if we go for, I think, rainforest, this has more of a direct mapping in that 0 corresponds to 0 degrees and 1 corresponds to 90 degrees, so pure vertical. So that works will work a little bit better for that. Our detail painters, we do also have a slope-based one there for this, which with this, because this is painting in some grass, so what I would actually do with this is that would put grass more on steep slopes. So I'd actually change this to drop that like of that. So it's now going to be, it worked fine with the normal version, but it wouldn't have worked so well with the slope version. And I should find that I get a little bit nicer generation of those textures now with that. And there might be a couple of other ones I need to update potentially. So the post-processing one for texture painting, that looks okay for putting snow on areas that are sort of flatter and everything. So that does look a little bit better for things like the rock and everything. So I'm pretty happy with that. We could probably tweak those a little bit further now, where the rock one, because it's a more direct correlation, I could change that time. So if I wanted it to be above 45 degrees, it's putting it. I would do like of that. Regenerate again, and I should find the rock texture is now more only in sort of steeper areas. So that's a bunch of changes that we've made to this. We've modified the biome generation so that it's now able to have different methods for picking the biomes. We've got the zone-based setup in there, which allows us to get more of that sort of nice grouping and having a spread of biomes as you move further out from the starting point. And that can apply to things like any of the buildings that get placed, stuff like that, which is great because those are often tied to the biome. And we made some improvements there for the slope, so it's a little bit more intuitive and it works a little bit cleaner in terms of the output there. But dive on in and experiment with it, see the kinds of setups you could create there with it, and yeah, see what kind of cool, interesting looking terrains you can make. Thanks, folks. Hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. It really helps out. It's really appreciated. If you've got any questions, chuck in a comment below. If there's other things you'd like to see me add to the procedural generation, then mention that also. If you are looking for the code for the project, the code is available up on GitHub. What I've started doing is you'll see there's multiple tags for each video with the code on GitHub. So there's a tag for where the project was at the very beginning and a tag for where the code was at the very end of it, just to make it a little bit easier if you're wanting to follow along. You can freely use the code in any of your own projects, commercial or non-commercial ones. That's no issue at all. And if you're trying to track down other videos, I've got a searchable video archive, which there is a link to that in the description. And if you're looking for other ways to support the channel, then I do have a Patreon, and there's a link to that in the description also. But until next time, bye.